Hey guys, hope you all are doing really well. Today we're going to be exploring chemical reactions and doing a fun activity towards the end of the lesson today. So, I just had a couple of some discussion questions to start out. First off, have you ever seen a fire? Just raise your hand. Okay, most of you. Have you ever helped cook with your parents, seen your parents cook? Okay, all of you. So, those are actually examples of chemical reactions, and you probably didn't even know it. There are hundreds of chemical reactions happening all around us every single day. So, we'll be getting more into that. Before I tell you guys the definitions of physical changes and chemical reactions, I wanted you guys to discuss within groups what you think those are. So within your groups of 4, discuss what you think the definition of physical change and chemical reaction is. So go ahead, I'll be walking around listening to what you guys have to say. Alright, so all of you are on the same track. So let's go over physical changes first. Physical changes are when you combine or mix 2 or more substances and it does not create a new substance. A good example I like to use, it's pretty easy to comprehend, is combining cereal and milk. So you pour your cereal into the bowl, right? Then you pour your milk into the bowl. Is it now a completely different food? No, it's just cereal and milk put together now. Another couple of examples are when you cut an apple. When you cut an apple, is it still an apple? Yes. Also, when you tear a piece of paper, is it still paper? Yep. So basically you're just changing what it looks like and what it is physically, but it is still its own identity. So you're still going from paper to paper, you're still going from apple to apple, even when it's physically changed. So as far as chemical reactions go, that's when the chemical makeup of 2 or more substances, when they're combined, creates a whole new substance. So a few easy ways to distinguish whether or not it's a chemical reaction is when you combine 2 things and you see fizzing or bubbling, you actually see a reaction. When you pour milk and cereal together, is it like bubbling and having some sort of reaction? No, it's just combining the 2. Now they're just sitting there together. So when you combine 2 things in a chemical reaction, you'll see fizzing, bubbling, stuff like that, and you'll also see a temperature change most of the time. That is if you're recording the temperature. So those are a few different ways to be able to identify if it's a chemical reaction. But it's basically when a whole new substance is created after the reaction. So just to make sure you guys are grasping the topic and the idea, I wanted to go through a worksheet as a class. We'll be doing it as a class, but you guys will each be turning one in separately. So here you go. Alright, so at the top you'll see it says identify which examples are physical and which are chemical, and just use the letters P and C along here to note that. So let's go through this. The first one is freezing water. So when you're freezing water, it's turning into ice, right? But it's still water. Even when it's ice, it's still water. It's just in a different physical form. So that means it's a physical change, correct? Next one, smushing a bug. So smushing a bug is also physical. It's still a bug, it's just smushed now, right? So, burning wood. We did talk about fires and stuff like that at the beginning of the lesson. So, burning anything, setting anything on fire, is going to change the chemical makeup of that item. So, when you're burning wood, it's turning into ashes. It's not staying as wood. It's turning into ashes now. Alright, number 4, clipping your fingernails. What do you think that is? That's going to be physical, yep. So you're just clipping your nails, now they're shorter, now that piece of nail is off of your hand. It's just changing the physical form, it's still fingernails. All right, now digesting food. When you eat food, it goes down into your stomach, right? The stomach acids are now breaking down what you just ate. Now it's separating it into the nutrients that your body's going to absorb and then getting rid of whatever your body doesn't need. So that's going to be a chemical because it's using acids and things like that to break down your foods. And now it's no longer a hamburger, it's now proteins and all these different things inside your body. Making shapes with Play-Doh. That's going to be physical because you're not turning Play-Doh into something else. You're just reshaping and molding the Play-Doh to shape something else physically. Number 7, adding milk to your cereal. Like I had discussed at the beginning of the lesson, that's going to be physical. You're not getting anything new out of it. You're just now combining milk and cereal to create milk and cereal. Does that make sense? Spoiled milk, so milk going bad. That's going to be chemical, because now it is no longer edible. It will make you sick, because the dairy in the milk doesn't last very long. Baking a cake. I did also mention cooking. So cooking is going to be, for the most part, a chemical reaction or a chemical change. For example, when you are grilling a steak, you start out with a steak, right? But it's raw, it's red, you can't eat it. Now, you cook the steak, now it's ready to be eaten, now it's edible. So you're still changing the chemical makeup of that steak, even though it went from steak to steak. It's now going from unedible steak to edible steak. And last one, number 10, cutting your hair. This is on the same lines of cutting your fingernails. Cutting your hair, it's changing how it looks physically, but it's still hair. Alright, good job guys. I'll be picking these up at the end of class, but it seems like you guys kind of grasped the idea of physical and chemical changes pretty well. So, now we'll be doing the actual activity of the day, which is called elephant toothpaste. First off, let's go through what items we're going to need. We won't be able to be doing this experiment individually with each one of you, so I'll just be doing it up front, and then you guys can just watch from where you're sitting. Now I'll be going through what materials we need to make the elephant toothpaste. First off, we're going to need 3% hydrogen peroxide. I don't know if your parents have ever used this on you, but if you get a cut or something, you pour that over your cut, and it basically sterilizes it and kills all the bacteria in that cut so it doesn't get infected. So that's a pretty common household item. Next off, we're going to need dish soap. Most everyone has dish soap. Then we have the dry yeast. People use yeast in bread. That's what makes the bread rise. We're going to need some measuring cups and spoons, an empty cup, warm water, which I already have some warm water in this cup, some food coloring. I'll let you guys choose a color that you want to use, and an empty water bottle to put everything in, and then safety first, some goggles. So now we're going to be going through and putting this all together. So let me get our empty water bottle, our 3% hydrogen peroxide. We're gonna need half a cup of this. So we're gonna pour it in. It's got us exactly half a cup. Now we're going to pour it into the empty water bottle. Now we got it in there. Now we're just going to do a nice hefty squirt of dish soap into the water bottle, like so. Now we're going to just take it and kind of mix it all together. All right, right, now that that's mixed, in your empty cup, we're going to now mix 1 teaspoon of yeast. So I already have that in there. There's the yeast. Pour that into the cup. And we're gonna do 3 tablespoons of the warm water mixed into the yeast. So 1, 2, 3. Now we're just gonna mix that up. Get the yeast sort of dissolved into the water. Alright, now the yeast is basically dissolved in there. Before we mix the two together, I'm going to add the food coloring. So what color do you guys want to do? These are the options. Green, orange, purple, pink. Purple? That one's going to be a cool one. This is gel food coloring, so I'm just going to pour some in there. Purple. Now I'm gonna lightly shake that up. You can see how purple it got. Now, we're going to add the yeast mixture and watch the magic happen. Whoa! Holy moly. Well, now you can sort of see the toothpaste aspect of it. It kind of came out really fast at first, but now you can see it's coming out in just a stream, which is why it's called elephant toothpaste, because it basically looks like a really thick tube of toothpaste. So yeah, there's the experiment. Some things I wanted you to think about after we did this part is what happened if we added more hydrogen peroxide, or what would have happened if we added more yeast, things like that. Just kind of think about that tonight. We'll be entering more chemistry tomorrow, but just think about what it might have done if it had more of each ingredient. All right, good job guys. That was chemical reactions.